Extended reality, or XR, acts as the core umbrella for the field of spatial computing. It unites three distinct but related technologies: virtual reality, augmented reality, and mixed reality. Virtual reality, or VR, fully replaces your physical environment with a computer-generated digital world, creating complete immersion. Augmented reality, or AR, overlays digital information onto your physical surroundings, enhancing what you see in the real world. Mixed reality, or MR, allows digital objects to interact with real-world geometry. Here, a virtual object can bounce off a physical surface, showing spatial awareness. XR systems function by tracking your position and mapping your environment. This begins with LiDAR and depth sensors that scan the room's geometry. This data builds a spatial map, allowing the system to understand where walls and surfaces are located. Next, SLAM, or simultaneous localization and mapping, anchors digital items to specific physical coordinates. Because the system maps the room, virtual objects remain fixed in place, even when you look away and look back. This persistence creates the illusion of digital items existing in your physical world. By 2026, XR has evolved far beyond handheld controllers. We now interact with the digital world through natural human behaviors. Eye tracking technology uses precise sensors to follow where you look, allowing you to highlight and select objects just by focusing your gaze. Hand gestures translate physical movements into virtual actions. A simple pinch can select, grab, or resize items in your field of vision. In high-end kits, non-invasive brain-computer interfaces detect intent, allowing users to navigate or trigger commands through thought, making the experience seamless. These input methods move us away from device-centric control toward a world-centric experience defined by intent and intuition. In extended reality, the enemy of presence is latency. This is the delay between your physical movement and the update of the digital image. We call this motion-to-photon latency. If the delay exceeds 10 milliseconds, your brain detects a mismatch, breaking the illusion of reality. To achieve true immersion, modern systems utilize edge cloud computing. This processes data instantly, keeping the digital world anchored and stable. The XR industry has transitioned from heavy, brick-like headsets to lightweight, wearable smart glasses. By moving heavy processing to an edge device or the cloud, we reduce the physical load on the hardware. Manufacturers use thin waveguides to project light directly onto the lenses, turning bulky equipment into a sleek accessory for all-day use. As XR devices map our private homes, spatial privacy emerges as a critical concern. These devices generate a three-dimensional replica of our living spaces, creating significant data security challenges. Utility is shifting from app-centric design to world-centric experiences. Instead of isolated apps, we are moving toward persistent digital layers that exist naturally within our physical rooms. Finally, the industry is prioritizing OpenXR standards. This ensures that these persistent digital layers function seamlessly across all hardware, preventing fragmentation and enhancing overall utility.